We are asked to find the symmetric partners of 2 pi over 3. Since we're dealing with thirds, we are in the land of 3. So instead of labeling this pi, I'm going to call this 3 pi over 3 here. And I'm going to refer to this instead of 2 pi, I'm going to call this 6 pi over 3. Let me go ahead and change that to a black ink. Therefore, 2 pi over 3 would fall right about here, with this distance here in blue representing pi over 3, 1 pi over 3. So in other words, the spot on the unit circle known as 2 pi over 3 is 1 pi over 3 short of pi. Folks, it's very important to understand that this blue pi over 3, that is the x in these formulas, not the 2 pi over 3. So this is not in the formula. It's the distance, it's the reference angle. You get to your spot of whatever they're asking you to find the symmetric partner of, and you find the shortest distance to the x-axis. Whatever that distance is in radians is going to be your x. So let's go ahead and finish this up. So one symmetric partner is going to be pi plus pi over 3. So pi plus pi over 3. But folks, remember, we are in the world of threes. So we're going to change that pi to 3 pi over 3. And therefore, one of the symmetric partners, which is going to be right here, is going to be 4 pi over 3. Okay, next we're going to do pi minus x. So pi minus x would be 3 pi over 3 minus pi over 3, which would be 2 pi over 3. Folks, that's the original point. Okay, so it's not necessarily a symmetric partner. Here, we're going to do 2 pi plus x. We're in the world of threes. Therefore, instead of 2 pi, we're going to do 6 pi over 3. We're going to add pi over 3 to that. Recall, that is our x, and we're going to get 7 pi over 3. 7 pi over 3 is going to be right here on our diagram. And finally, 2 pi minus x is going to be 6 pi over 3 minus pi over 3, otherwise known as 5 pi over 3. And that's going to put us right here on our diagram. Therefore, the symmetric partners of the original request of 2 pi over 3, the symmetric partners are going to be 7 pi over 3, 5 pi over 3, and 4 pi over 3. Folks, one quick addendum to that last problem. Here we had 7 pi over 3 as one of the symmetric partners. Technically, that is not within the reference range of the unit circle. Recall, the reference values are located between 2 pi and 0, with the inequality being less than or equal to 0, but just less than 2 pi, meaning 0 is a reference value, whereas 2 pi is not considered. So 7 pi over 3, in the world of threes, this would be 6 pi over 3. So 7 pi over 3 lies outside of that reference value zone. So in order to legally replace it with a reference value, we need to subtract the period. So if we subtract the period, we would do 7 pi over 3 minus 6 pi over 3, because that's the legal way to move from outside the reference value zone to get within the reference value zone. So if we take 7 pi over 3 and we subtract 2 pi, which is the period of the unit circle, 2 pi is the same as 6 pi over 3. The reference value within, the symmetric partner that is within the reference value would be pi over 3 instead of 7 pi over 3. And look, folks, that makes sense. That's our x value. That's going to be from 2 pi and then adding our x value. Our x value is pi over 3. So we could just say from 0 to pi over 3 to stay within the reference values. So this is our final legal symmetric partner. Next, we are asked to find the symmetric partners of 10 pi over 13. Folks, it's very important to understand this is not your x value in these formulas. That is not how this is done. What we do is we plot 10 pi over 13 on our diagram, and then we find the shortest distance between that point and the x-axis. That becomes our x. So here we are. We're in the world of 13s. So instead of writing this as pi over here, I'm going to use 13 pi over 13. And instead of writing 2 pi, I'm going to write 26 pi over 13 over here. 10 pi over 13 is going to put us about right here. That is what they want us to find the symmetric partners of. That is not the x. Folks, this is the x in blue, the shortest distance between the plotted point and the x-axis. So for this problem, 3 pi over 13, which is the distance between 10 pi and 13 pi, 3 pi over 13, that's going to be our x all throughout the rest of this problem. So x is going to equal 3 pi over 13. So let's go ahead and compute the symmetric partners. In the world of 13s, we're going to change that to 13 pi over 13. We're going to add 3 pi over 13, and we're going to get 16 pi over 13. That's going to put us right here. That is our first symmetric partner. Next, we're going to do pi minus x. We're going to do 13 pi over 13 minus 3 pi over 13, and we're going to get 10 pi over 13. Folks, that's our original value. So it's not technically a symmetric partner. That's what we're trying to find the symmetric partners of. Let's now move to 2 pi. We're going to use 26 pi over 13 because we're in the world of 13s. We're going to add our x value. Our x value is here. It is not 10 pi over 13. X value added is going to get 29 pi over 13. That's going to put us here, right? We're going to do one revolution to get to 26 pi over 13. Then we're going to do 3 pi over 13 more, because that's our x, and we're doing 2 pi plus x, and that's going to put us at 29 pi over 13. But folks, technically that is not a reference value of the unit circle. The reference values, recall, are between 2 pi and 0. And note, that has an equal sign. The reference values are greater than or equal to 0, but they are less than 2 pi, meaning 2 pi is not a reference value, 0 is. So we're going to go ahead and change that to a value within this domain, within this range, however you want. Within this interval is probably the best way to say it. And our final answer here for the symmetric partner is going to be 3 pi over 13. Next, we're going to go ahead and do 2 pi minus x. So here, you can see it on the diagram. 2 pi in the world of 13s is 26 pi over 13. We're simply going to subtract 3 pi over 13, and that's going to put us here at 23 pi over 13. Folks, these are our symmetric partners. 23 pi over 13, 3 pi over 13, and 16 pi over 13. And our original value that they asked us to find the symmetric partners of is 10 pi over 13. Next, we are asked to find the symmetric partners of 11 pi over 8. In the world of 8s, we will be here at 8 pi over 8, and here at 16 pi over 8, representing pi and 2 pi respectively. 11 pi over 8, we're going to plot it right over here. Again, 11 pi over 8 is not our x in these formulas. Rather, the x is going to be the positive distance from 11 pi over 8 to our x-axis. So this is going to be 3 pi over 8 that we're going to use. That is our reference angle. Not negative 3 pi over 8, but the reference angle is just right there. That's 3 pi over 8, which is the distance between 11 pi over 8 and 8 pi over 8. Now that we know that our x value is going to equal 3 pi over 8 for each of these formulas, we can proceed. Let's do pi plus x. Pi in the world of 8s is 8 pi over 8. We're going to add 3 pi over 8, and we're going to get 11 pi over 8. Folks, it turns out that's the original. That's the original value that they want us to find the symmetric partners of. That's okay. Let's keep moving. We're going to have 8 pi over 8 minus 3 pi over 8. That's going to give us 5 pi over 8. That's going to put us right here at 5 pi over 8. That is one of our symmetric partners. Let's now move to the other side of the diagram. We're going to have 2 pi written as 16 pi over 8 plus our x value, which is 3 pi over 8. That's going to put us at 19 pi over 8. That's going to be one revolution, which would be 16 pi over 8, and then another 3 pi over 8 would put us right here at 19 pi over 8. Folks, that is outside of the reference range. So we're going to change that to 3 pi over 8. And we know that's the appropriate result because that x distance is 3 pi over 8 from our initial plotting of the 11 pi over 8. Let's finally do 2 pi minus x. Let's go ahead and do it right here on the diagram. Here is 2 pi in the world of 8s. We're going to subtract our x value, which is 3 pi over 8, and that's going to put us at 13 pi over 8. Folks, these are our reference values. 13 pi over 8, 3 pi over 8, and 5 pi over 8. And again, the original was down here in green, 11 pi over 8. In our next example, we are asked to find the symmetric partners of two radians. And we are not going to use the previous diagram here because you're probably not going to have that on your homework or your quiz. So here we go. We are in the world of radians. Okay, so we're going to call this pi 3.14. We're going to start at 0, and we're going to call 2 pi 6.28. Okay, we're going to go ahead and plot 2 radians on this diagram. Recall, a radian along the unit circle is simply the length of the radius. So this would be 1 radius, otherwise known as 1 radian. Okay, using this as the length of our radius, that would be 1 radius approximately, and then this would be 2 radiuses or radii. So I'm going to put right here as 2. That's what they want to find the symmetric partners of. Now, folks, that is not our x. Our x is going to be this distance here. All right, now, how do we get that distance? Well, if the distance from 0 to pi is 3.14, and the distance from 0 to 2 is 2, then our x value is going to be 3.14 minus 2. And we're going to use, instead of 3.14 minus 2 for this distance, we're simply going to call that pi minus 2. So our x value for this entire problem is going to be, x is going to equal pi minus 2. Okay, let's see where that math takes us. We're going to have pi minus x. So we're going to have pi minus 2. That's going to give us pi minus pi plus 2, or plus 2. Folks, that is our original location. So that is not a symmetric partner. That's what we're challenged with finding the symmetric partners of. So let's now do pi plus x just above it. So we're going to have pi plus pi minus 2. That's going to yield 2 pi minus 2. Okay, so 2 pi is going to take us a full revolution here. That's going to be 2 pi, and then we're going to subtract 2. So 2 radians, the length of 2 radians, if you're looking at this arc right here, the length of 2 radians is going to put us right here. All right? This distance here is the same distance as that original orange arc, but going negative from 2 pi. Okay, let me label that. That is going to be 2 pi minus 2. That will be a symmetric partner. Okay, let's move down here. So now we have 2 pi plus x. That's 2 pi plus pi minus 2. That's going to give us 3 pi minus 2. Okay, let's see where that takes us. Okay, here, if we go all the way around, that's 2 pi. Then we go to 3 pi, which will put us here. Then we're going to subtract 2. 2 is the length of that original orange arc. If we go backwards from 3 pi, backwards 2, it's going to put us right here. Sorry, it's going to put us right here. That is going to be 3 pi minus 2. Or we could call that positive pi minus 2. All right, because 3 pi minus 2 is not going to be one of the reference values. All right, so we're going to change this. We're basically going to subtract 1 period from it. That's what you do to legally get back into your reference range. You move in aliquots of the period. So this is too big for the reference value zone. We're going to subtract 1 period, and we're going to end up with positive pi minus 2 as the location. Finally, we're going to do 2 pi minus x. So let's go ahead and do this. 2 pi is 1 full revolution. And then we're going to subtract x. So we're going to be right here. We call x, our x value for the formulas is pi minus 2. So let's go ahead and do the math on that. We're going to have 2 pi minus, parentheses, pi minus 2. And that's going to end up with pi plus 2. All right, let's see how that gets us to the same location. All right, our pi value will bring us to this location here at 9 o'clock if this was a face clock. And then we're going to add 2 more. If we add the length of that arc that you see up above, it's going to put us right here. Here's pi. We're going to add this length of that arc, and we're going to end up right in that location. And that is going to be pi plus 2, our third and final symmetric partner. So our symmetric partners are pi minus 2, 2 pi minus 2, and pi plus 2.